Okay, so now you finished the last part of the lab and you're just about ready to go home. But before you do, you gotta listen to me talk about what all your data means in this last part. It's kind of interesting. Plus, you know, you have to. So, you're going to have to. All right. So what you should have found in this part here is with your pendulum is if you take a look at your plot, what you have here is your period right here and the displacement right here. Okay? What you should have seen is that your period should start at about 1.5 seconds or so, and it stays pretty constant up until you get about 20 degrees, and all of a sudden it just takes off. Like that. Now why is this true? Well, it's true because, as it turns out, below 20 degrees, sine of theta is about equal to theta. And that's true if you have theta in radians, not in degrees, but in radians. The math behind all this gets complicated, and it's really beyond the scope of this class, so we're not going to talk about it too much. In fact, we're not going to talk about it at all. But the impact of it is what's important, because of this observation that the time period doesn't change as the displacement varies between 0 and 20 degrees. This is the background for one of the most important discoveries in modern times. Well, not even modern times, but going back quite a bit. This was the principle that allowed the discovery of the pendulum clock, which was the first accurate timepiece ever made. Because even as the pendulum slowed down and its displacement decreased, it's still the period didn't change. Pretty neat, huh? So, who was the guy who discovered all this? Well, you actually have heard of him. I'm sure you've heard of him, unless you've lived under a rock. And based on the look on some of you, yeah, it's probably true. Okay, so if you haven't been living under a rock, you've heard of the guy. And you're probably going to say, well, I never heard of the guy who discovered the pendulum clock. No, you heard of him for some other reason. Okay? By the way, I still have this thing here if somebody hasn't claimed it yet. The guy's name who did this was Galileo. Now, the reason you've never heard about it is he discovered the principle, but he could never figure out how to make a clock. I think it was his grandson who actually figured out. Galileo spent all his life trying to figure out how he could make a clock out of this, an accurate timepiece, but he could never get it to work. I think his grandson did. Maybe that's why they call him grandfather clocks. I don't know. I made that up. Not the part about his grandson, just the part about the grandfather clock. Okay, so now that you've seen this, what I want you to do is put all your crap away, shut down your computer, turn off your monitor, and get the hell out of here, okay? Thank you very much.